So today what we want to talk about are triangle congruence theorems, or how can two triangles actually be congruent to each other. When we're talking about being congruent, we want to remember that congruent triangles have three congruent sides, meaning three equal sides, and three congruent angles, three equal angles. They're the exact same triangle. Okay. However, triangles can be proved to be congruent without showing that all three pairs of sides are congruent and all three pairs of angles are congruent. Just like when we were trying to prove that triangles were similar, being similar gave us 6 pieces of information because we had 3 equal angles and 3 proportional sides, but we didn't have to show all of that to prove that they were similar. Triangles being congruent fall into that same category. I actually find congruent to be a little easier because I don't have to worry about whether the sides are proportional. The sides have to be equal. And so we're going to talk today about what are the things that we can do to prove that triangles are congruent. We have actually several ways. Today we're really going to focus on 3 of them, and then we'll get the other 2 later. But these are all of the ways that we can prove that triangles are congruent to each other. So let's get into detail about these methods. All right, so a little dramatic music there for you. Now, if 2 angles in one triangle are congruent to 2 angles in the other triangle, then the third angles must also be congruent. We talked about that the other day when we had the angle-angle theorem for similarity. They have to add up to equal 180 degrees. So, if 2 triangles have 2 pairs of congruent angles, then their third pair of angles must be congruent. But do the 2 triangles have to be congruent? No. That proves they're similar. That's what we spent all that time on the other day. Angle-angle proves that they're the same shape, but it does not show that they are the same size. We had many of them the other day that the angles were equal, but they were 2 very different sized triangles, so they would not be congruent. So how can we prove that 2 triangles are congruent? Not just the same shape, but the same shape and the same size. So first one up, side, side, side. Same idea as side, side, side the other day. It's just that instead of proving that all 3 pairs have the same fraction, the same proportion, we just have to show that the 3 pairs are congruent to each other. So I want this side congruent to that side, this side congruent to that side, and this side congruent to that side. If I get 3 congruent sides, then I have 2 congruent triangles. Example number 1. Now, things to remember. They don't always mark everything on the picture. That's why we reviewed all of those types of angles the other day. So when I look at this picture, I start to think they're not congruent because I only see 2 pairs of congruent sides. I've got this pair congruent and I've got this pair congruent. And I'm like, well, that's only 2 sides. I have to have 3 sides. But when I look at this picture, what I have to realize is the third side of the triangle is a shared side. So this side is congruent to itself. It's the same side for both triangles. So those would be congruent. So they don't mark it, but I can mark it and see that it's congruent. Side angle side, again, just like with the similarity theorem, except for the fact that instead of these sides giving me proportions that are the same, I want them to actually be the same. So it does have to be 2 sides and the angle in between it. Just like the other day, SSA doesn't work. Spells a bad word on my paper, so I don't want to include that. But if I can prove that 2 pairs of sides are equal and the angle in between, then I can show that the 2 triangles are congruent. So if I look at this example, the triangles are turned all kinds of different, but I have 1 pair of equal sides, 2 pairs of equal sides, and then the angle that is between those 2 sides is congruent. So then I know that these 2 triangles are congruent. Example number 3, equal sides, angle in the middle, side, angle, side. Now, it is important, again, just like with similarity, everything has to line up. So I want to make sure that the angles that are the same, you know, when I write them, that I put them that match up, just like when we were doing it with similarity. So when I look at this one, the corresponding vertices, the ones that would go together, A goes with D. And then at the end of D is E down here where the one ticky mark is. So E must go with C because they're at the end of the same segment, which means that B must go with F. So you want to make sure that you know what all the corresponding parts are so that we can write their names in order. All right. Why are these two triangles congruent? Well, I got one pair of equal sides, one pair of equal sides, and then they have a shared side, so that one's congruent. So this one must be side, side, side. Now also, what matches up? So I look, okay, these two sides are equal. Well, D is equal to itself. And then A must go with C, and then B is congruent to itself. And then we can get everything in the right order. All right, so if I'm looking at these, let's see, I've got an equal side, and I've got an equal side, and I've got an equal angle. The problem is this angle is not between the two equal sides. This is giving me the SSA, or if you were to write it down here, ASS, not okay. That doesn't go on my paper. So these triangles are actually not congruent. Another one that we can use, now this is an exception to that rule. I just said that SSA doesn't work, and it really doesn't work, except in one case. There is one case of SSA that works, but we can't call it SSA. We're just not putting that on our paper. But it only works if the angle is a 90-degree angle. That is the only SSA situation that works, and that is when the angle is a 90-degree angle. So we call this the hypotenuse leg theorem. If you have a right triangle, so we know it's a 90-degree angle, and we have one of the legs and the hypotenuse that we know are congruent, then we can use hypotenuse leg to show that it's congruent. It only works for right triangles. So this is the only case of SSA that works. It has to be a 90-degree angle. So let's look at an example. All right, so we are given that PS, that's this long side, is congruent to QR. That's the hypotenuse of these right triangles. We know that these are 90-degree angles. So S and R are 90-degree angles. So I've got these sides are congruent. Let's see, it's a 90-degree angle. We have a shared side. See how these big triangles down here have this shared side? It's not marked. That throws us off. We have the hypotenuse. We see that. We're like, we don't have a leg. But we do because they're sharing this side down here. Shared sides get used a lot. Watch out for those. So we know QR and PS are equal, but we also know that SR is congruent to RS. And so that gives us a hypotenuse and a leg. So we know that it is congruent.